All right. Well, welcome everybody. Why don't we get started? Welcome to APEC 3611W. I'll probably drop that W whenever I say it from now on, where we're going to talk about environmental and natural resource economics. So today, I want to do what you probably expect on the first day of class. I want to talk about just an introduction to the content, a quick review of the syllabus and a more detailed review of the schedule, but also give a big picture take on where we're at with the environment in general, but also environmental and natural resource economics as a field. Um, so for that, let's get started. Um, just introducing myself here for a moment. I graduated with my PhD in the Department here of Applied Economics at the University of Minnesota in 2014. And immediately after graduating, I worked just down the hall, actually, at the Institute on the Environment. It's in the Livestock Pavilion building, if you ever noticed that one. And so there I worked for 5 years, first as a postdoc and then a self-funded researcher for a while. It was kind of fun. Although it was terrifying because that meant I had to fundraise for myself, and if I didn't succeed, I was fired. That's never a fun position to be in. So now I'm really happy that I made it back onto the faculty here in applied economics. That was back in 2020 when I started here again. And I was just tenured last year, so now I can say whatever I want. Just kidding. But other things I've done is I've worked extensively in this area, thinking about the environment and economics. And I've worked extensively with an organization that we'll see and discuss many times throughout this, called the Natural Capital Project. But more recently, we actually founded a spin-off organization of the Natural Capital Project. We call it NatCap Teams, or the Earth Economy Modelers. And so that's is a departmental research center here in applied economics. And we're getting big and growing. It's kind of fun to see it getting off the ground. It's only been up for about a year and a quarter. So besides Earth economy modeling, I'm also just interested in coding in general. I love it. And specifically the open source subset of coding, especially in this age of AI, where we wonder, what is the what is the point of doing research when there are these AI agents who can also do research, et cetera? I've come to the strong belief that the key thing for us is replicability and understandability of all the science that we do. And for me, open source science is the correct answer. And so this will actually be a theme throughout because it's fundamental to sustainability. Excellent. It's really good to get to know you. We might do another round of introductions at some point, so that you all can get to know each other as well. But I want to talk about the big picture. And, one of the questions was asking you why this course. There's lots of good reasons. Totally happy for that it fits the graduation requirements. That's the point of school. But I also am going to approach this course from the perspective of the environment matters. Saving the environment matters. And so I think you're going to see a lot of, I guess, passion from me coming out on this topic. If you did take my 1101, it probably even kind of snuck into that course a little bit, just because I can't help it. But this is a topic that just I'm absolutely passionate about, and so I want to give a little bit of why I feel that way today. Or in other words, why we should care about the environment, but specifically from the perspective that economics brings. And so we're in a state of transition right now. But I want to give some historical context. And so, first off, I'm going to give a running disclaimer. If you have taken any of my previous courses, I am going to reuse some stuff. So just nod your head along with this. I know I've used this one before. But what is this? This is a graph of the surface temperature on Earth for the last 100,000 years. And what do we see in this? Let me get my pointer up. We see number one, wild swings. This is as glaciation happens and the temperature swings up and down. It was actually quite a bit cooler before modern times. So really, it's two things. It was cooler, and there were these massive fluctuations. And so the one thing I would note is there was big change all of a sudden here about 15,000 years ago. And this is when we entered a new geologic era that is called the Holocene. And so the Holocene is characterized by two things. Number one, a little bit warmer, but vastly more important, there were not dramatic swings in temperature. And this led to a stability that many scientists call the Goldilocks zone, where suddenly all sorts of things relevant to our current life started to emerge. And so right here, that's the beginning of agriculture. It's a little small on the screen. Here is the first great human civilizations, the Sumerians and the Egyptians. And nowhere in this history did that exist. And so we're in kind of a unique special Goldilocks zone here. And that's number one, really, really good. But number two, emphasizes the importance of staying in that region. And there is reason to worry, some people even think and argue that we're on the edge of going into a brand new ecological zone, leaving the Holocene and going into something called the Anthropocene. And for sure it's real if it's reported in The Economist. And so, right, we're in an economics class. So what better form of proof of this concept being important is there than it being the cover of the keynote publication that economists tend to read? So I'm joking a little bit. There's actually a fair amount of scientific debate of what actually counts as a geologic era, but we won't get into that. Instead, what I want to do is just highlight that we're at a big moment of change. And I think I actually like this graph as the one for understanding a broad framing of the questions we're going to address in this course. And so this is kind of a fun three-dimensional plot here. But what you can see is, number one, there's the passage of time, basically moving towards the audience. And so that's this axis here. And then there is stability, and it's decreasing. And why is that? Well, if you think about where within a bowl would a marble be stable, it's in the bottom of the bowl, right? And so there's a stable point here, big stable point here. But then finally, the key variable going left and right is the global temperature. So climate change, big deal. That's what changed to define the Holocene, and what we worry is changing with modern day anthropogenic climate change. And that's going to be a fundamental basis of this course, is adapting to that, understanding what that does to the sustainability of our economies. A particular way we'll look at it is thinking about it from the perspective of thresholds. And that's really what this graph is showing, is the choices in front of us. You could think of us as being right here, right now, where that Earth is. And we have choices in front of us, such as how much should we emit? And if we emit a lot, we'll go towards this side, the hotter amount of climate change. But we also have options for stabilizing the climate and trying to push it in this direction. The sort of scary possibility, though, is that there might exist, and there's a lot of evidence that there do exist, feedback loops where once you cross over some sort of threshold that is this dotted line here, the rate of change starts to accelerate. And we would then see this sort of split where we have equilibrium where the world might end up down here in something called hothouse Earth, or we could dodge that planetary threshold and start emitting a lot less right now, and end up in not ideal, but still a whole lot better of a equilibrium. It's still the bottom of a bowl, so it's still sort of stable, but we don't have these high temperatures. And so that's really the framing that we're going to use throughout this class of how do our decisions push us not just on temperature, but on a whole variety of different things towards different types of equilibria. The one that will be seen throughout is this idea of planetary boundaries. Who's heard of planetary boundaries as a concept? Yeah, it's one of those ones that kind of is just barely making like public recognition. There's like some rock star statisticians, if that's even possible, that talk about it. Johan Rockstrom, other people like that. Really compelling speakers, people that can give TED Talks about stuff like this and really motivate people. But it's been just one way of expressing the sort of peril that we might be in. And that's in this particular case, here's one of the recent papers, Earth Beyond 6 of 9 Planetary Boundaries. Like, oh no, we should do something. We could talk about the science behind each one of these different axes, but we won't get into that. That's more for an environmental science major. But it's the ones you would expect. So climate change is a big one. Biospheric integrity, that's another fancy way of saying biodiversity loss or losing species. You know, you can see genetic integrity. That's kind of the key word for species. Land systems change is another one we'll spend a whole lot of time talking about. But the point is, there's this safe operating space, this green area here. And for a couple of them, we haven't yet surpassed what they identified as the planetary boundary. But unfortunately for 6 of them, and there's actually a more recent article that goes even further, we're in this sort of tenuous space where we're past the boundary and we're kind of waiting for the other shoe to drop. One thing I would say, though, is that this course is going to emphasize also hopefulness. And this one here, stratospheric ozone depletion. Who heard about the ozone hole? Yeah? You know what happened? We solved it. We had scientists who identified a problem. The ozone hole was being created by CFC, chemical used in refrigeration. And we came up with the Montreal Protocol, which solved it. It would have been a really awful thing if it did happen, like lots more skin cancer. But this is one of the planetary boundaries that has not been surpassed. And essentially, it was because of successful collective action. There are some reasons why other challenges are more harder than that. That one was, just one hole in one small spot and just one chemical involved. But other things like climate change might be much harder. But the point is, we can act collectively to solve these problems. Okay, so the key takeaway from this is that there are biophysical boundaries, and they should not be crossed. So we should tread carefully. And in particular, in this class, we'll talk about how our economy should not push these boundaries, and we'll also be very specific about what are the costs to the economy from surpassing them. And so, yeah, this is a very popular framing, but I don't really like it that much. I'm going to use it because it's so common. It's just that I don't find it very useful. It's like scary. Yay, we're scared. Now what? Well, at most that can get you depressed, and depression doesn't lead people to make positive change on the environment. And so it's important to know the status, but it's not very useful. It's also a little bit annoying to me in that it doesn't have any information about what's pushing these variables around and what's causing us to possibly surpass the planetary boundaries. And so I actually want to introduce the framing that we will talk about. And this is small for now, but don't worry about it. We'll dive deep into this in the next class. It's called the Safe and Just Corridor, or also colloquially known as the planetary donut. And the idea is, so I'll draw a better version here so you can see it. We have planetary boundaries. You could also substitute in many other possible frameworks or different ways of measuring the planet, but basically things that we don't want to do too much harm to. And so there is going to be, so you can see some of them would be outside, some of them would be inside. What the planetary donut adds to this is humans. This, as I said, the planetary boundaries is just the biophysical state of the world, but it doesn't say anything about the underlying people and the choices they make and the well-being of those people in the system. And that's what the donut, first introduced in 2017 by Kate Raworth, captures, I think, in a really nice way. She calls the planetary boundaries the ecological ceiling, but adds to it an important layer that she calls the social floor. or foundation, but I'll go with floor with a nice metaphor. And you can see why it's a donut, obviously, just the shape. But the idea is for any of these indicators, we don't want to go outside of the planetary boundary, but we also have to ask ourselves, are we producing the things that are necessary to create the social foundation? And next lecture, we'll talk through those in detail, but things like producing enough food, having healthcare, a safe place to live. These are things that are produced by the economy, and we don't want to do without them. This is a way of doing away with the idea that it's the economy versus the environment, but rather it's jointly optimizing these trade-offs. There are certain types of economic activity that are really bad, like CFCs in refrigerants that caused the ozone hole. But there are also things that we really want, like universities, or the option to have a safe and fulfilling, welfare-filled life. And we'll actually talk about what that means in economic terms. So the question that Kate Raworth talked about is, what policies can we have that don't fall below and undershoot on the amount of production of key things we care about, while also not having the problem of overshooting? And instead, how can we stay in the safe and just orbit? There's been all sorts of other work. 2023, and actually Kate Raworth just published in Science, like the formal paper that describes this and quantitative metrics in detail. And so there's all sorts of ways you can look at it. There's my animation. Why aren't you moving? Uh-oh. Appears my PowerPoint is frozen. Let's try this again. There we go. And so there's all sorts of other donuts. This has become a popular sort of organizing principle. And so I love this framework a lot more than just planetary boundaries by itself, because it includes the human. But it still drives me crazy, because even though it includes the human agents in this system, it doesn't answer questions that are what are fascinating to me. Is like, what should we do? What policies might get us into that safe and just corridor? And so that's going to be the framing throughout this class, is let's analyze those policies. We need to understand the Earth systems at play so that we can be smart enough to figure out what sort of policies might work or what sort of impact they'd have. But what are the actual levers we can pull? Okay, so I want to back up a second. This one is personal. What is the economist's role in solving all this? And I bring this up because usually I find myself talking to ecologists or conservation biologists or people like that are less focused on economics as a discipline. And I feel like I'm always apologizing for economics. Who loves capitalism and unlimited economic growth? Well, nobody wants to raise their hand. But who likes having tasty food? Yeah, okay, so there's a tension here. A lot of the old way of framing environmental economics was the environment versus the economy. And this has been very successfully used by various interests in our society to polarize us and not care about some of the things that we actually do want to care about. And one of the sides of this polarization that I see actually is from the environmentalist side, just thinking that anything an economist says is going to be bad because it's about perfect markets, capitalism, endless growth, and things like that. These are all things that are important to address, but actually, and I feel this strongly, economics is a incredibly useful lens to look at these questions. And so it's not one. But regardless, I always feel like I'm apologizing for being an economist. And so I have these slides to talk about why economics has been really successful at what it was meant to do. So this is also caveating that it has been problematic at things it wasn't intending to do. So what is that? I mean, basically, economics did phenomenally well at improving physical consumption. And so, where did modern economics get a start? You might be able to trace this back to right after World War II. We created systems of national accounts to define, among many other things, GDP. And right now, everybody reports GDP constantly and obsesses with it. And it, makes and breaks presidents and policies. And that was essentially a measure of how much can the economy produce. And that's really important when you're, especially in a wartime economy, and the success of your nation's military depends on literally producing tanks or something like that. And so it's a good measure for the well-being that you could get from physical consumption. And we're going to return to these systems of national accounts, and we're going to extend them to include the environment. That's just kind of like a preview. But basically, these were navigational tools that were designed to help us make it out of the Great Depression. And we'll be learning a lot of those specific tools like general equilibrium, growth models, supply and demand, basically, or the circular flow diagram that you maybe were exposed to in Econ 1101. But the result of this, it's really easy to forget how big of a change we've had in the last 100 years. So let me just throw up some statistics. Producing more stuff, why is that good? Well, it is, if distributed properly, something that can reduce poverty. And so here is the world population living in extreme poverty from 1820 to 2015. And here's the depression. You can see this is a drastic change. If you were in this area, the odds that you would be struggling to have enough calories to survive would be 90% or more. Looks like more like 95%. But now it's the other way around. And if this graph continues, we've had a drastic reduction in poverty. And this is, maybe you could debate that one. Like, what is poverty? Is consuming things really the answer? Well, let me give you one that I don't think you can debate. We are living longer. That's just factually true. And so here are life expectancies at birth plotted from 1770 to 2021. And you can see, again, at about the same point, all of these started accelerating upwards. There's been obvious lags in one region versus another region. So, basically high-income countries are way higher on this than Africa. And what do you see here? What's this little dip? What's that? Yeah, COVID. So it started going back up again, but not as fast as we'd like. But basically, this is also consumption. It's just healthcare consumption, the clean water, sanitation, access to medical services. And that's, I think, really telling because if you look at in America, what was the life expectancy at the turn of the century, it was 42 years. That wasn't that long ago, and 42 years is not that old. And it's sort of relevant to me because I'm 43 years old. And so every year I update this. And last year when I got to show this slide, it was like, yeah, it's exactly my age. Well, now I'm dead. No, I'm kidding. But the point is, this is not debatable. There's no way you can debate these statistics. You might be able to argue, is it good or bad? Is it worth it? Is it not? But I'm pretty happy I'm still alive here. And so I'm happy for this trend upwards that we see. And it really is a dramatic shift. You can go further on this. Less homicides. One of the most controversial books, I think, in the last while was written by Steven Pinker. It was on it's called The Better Angels of Ourselves or something. I'll send it around. But it was a detailed statistical accounting from an anthropologist on how he argues our world is getting less and less violent. There's some outliers, like notably World Wars I and II, but overall, the probability that you will die a violent death seems to be going down. I actually read this book right in 2016. I was feeling depressed about the state of the world, and I decided I needed to pick me up. So I wanted to read like the most optimistic book I could. Bad choice. It starts off like the whole first half of the book is the history of violence. And that's sort of depressing, it turns out. We watched torture as a thing, like public execution, and people didn't feel weird about this. I don't know. I think we've made some changes for the better on that. Okay, so those are the indicators, but what did economics specifically do? Well, we built tools that describe the economy, and it was rather successful. The way we're going to be shifting our thinking is discussing some of the specific tools that fit within this box economy and address how they do a good job or bad job of simultaneously accounting for the value of nature and the value of producing things that we like. But I just want to first talk about its successfulness overall in the economic domain. Here's an interesting plot. This is time, and obviously it's too small to see, but I'll walk you through it. You can just see the visual details here. The US has experienced 34 recessions since 1855, and they're going to be denoted by pink. And so the blue areas are the areas where we're not in recession. And so what do we see? Well, there's a whole lot of recessions for the left side of this graph, and starting again at about that same point. This is what's referred to as the Great Moderation in economics. There's huge and contentious debates about what caused this moderation, but it does appear to be the case that we have less fluctuation towards the negative side on our economic cycles. And one of the also very contentious arguments is that essentially economics provided tools to understand how do economies grow, how does inflation happen, how can we manage those things. And so you can spend a whole other course on debating this point, but it remains, I think, evident that there has been this broad proliferation of tools that economists use to try to better manage the economy. All the various levers that we could pull, like exchange rates, printing of money, things like that, are ones that might, and I would argue do, in fact, contribute to this stabilization of our economy. So yeah, so they're good. And what are those tools? Well, the things you learned in your other econ classes. And so here's just one example that combines a whole bunch. This is a production possibilities curve with a price line. You probably didn't learn the contract curve, but you can dive deep. You go, did anybody have an Edgeworth box in any of their classes? A little bit. That's this inner part here with the squiggly lines.
I think for intermediate.
Okay. It's one of those things that they used to always teach, but I think they're moving away from it. But whatever, you won't learn it in this class. But it's one of the more hard things to understand. It's how two people might exchange things in an economy to maximize their surplus happiness. But yeah, so this is what we will return to this in the form of. We'll be talking about how do individuals make decisions. And we'll use environmental decisions as the context, but we'll use the basic tools of economics. And that's at the micro level. This is like a summary of the greatest hits of micro econ. And down here, this is like a summary of the greatest hits of macro econ. This is the circular flow diagram talking about how households buy goods and services from businesses in the products market, but that they also provide inputs to those companies in the terms of like their labor. We'll get into this. And this is, the sort of tools that we're going to see. The problem that I have, and that we'll address throughout this course, is that these tools were seen of as being separate from the environment. And so it might look a little bit like this. The origins of environmental economics really thought about it from the point of view of how do you extract various resources, put it as a full box. And that's important because those are inputs to the economy. This is the old way of thinking about it. And this is what natural resource econ economics is. Okay, so that's one of the words in our course title, right? We're environment and natural resource econ. And so the origins of this is thinking about how do we optimally extract like minerals from the ground, or oil from the ground, or maybe they're renewable and like it's a forest that regrows, but we don't want to cut it all down because then it doesn't grow back. These are ways of optimally extracting things from the earth to be used in the economy. A slightly less old one is to think about it in the environmental econ way of thinking. So that's the other word within our title. So we have the earth and the economy, and it adds a new arrow. It still recognizes we have resources, but we also have wastes. Waste, I should say. So like pollution. And that's another thing that needs to be considered. So it's slightly less old, but you might tell by my framing that I still don't think that's sufficient. And a slightly better version is not to have the two things side by side. There's this duality very common in Western thinking. So take a philosophy course, you'll appreciate the deepness of the thinking here, that the earth and the economy are separate, or that humans and non-human things are somehow very different. I'm going to argue throughout this whole class that that's the wrong way of thinking about it. That instead, we think about it as the economy, whatever. The economy is embedded in the biosphere, or the earth, or something like that. And all these flows, they are important. You still will have resources flowing in and wastes flowing out. But it's not so simple that there are many complex linkages. And so, you could have lots of arrows. And we want to think about this as a jointly determined system. And so, okay, there we go. And so that's the reality. I think things like climate change started to express this as an important thing that we needed to take into account, where essentially the economy, so here's that blue box that contains just the economy, grew too big. And so the whole planetary boundaries thing can be simplified down into our economy's gotten too big for the size of the biosphere, or more specifically, the regeneration capacities of that biosphere that create the fundamental opportunity to live like this. And the problem, I would argue, is that we have no adequate navigational system. GDP as a navigational system in our system, growth economics, that worked when the economy was small compared to Earth. But it's not so relevant when our problems have shifted to the sum of producing, yes, but not producing too much. And so the course that we're going to have here, it is called Natural Resource Environmental Economics, but I'm going to petition actually for the next year to change it now that I've taken over this course. And I think we're at a pivotal moment where starting with climate change, but now also considering many other simultaneous crises like the nature crisis or species loss, are in a situation where there's growing energy, excitement, and I'll talk about that more, behind the idea that we need to create new models. And I'm going to call these Earth economy models. And so although we'll still talk about the sort of greatest hits that you would expect in natural resource and environmental economics, this whole course is going to be reformulated so that those aren't just separate things. And instead, it's going to recognize how we can tie them together with economy-wide models. Basically, to summarize, before this course was entirely microeconomics, thinking about optimal extraction or pollution taxes or stuff like that. But now that the economy has grown so big, we're going to switch from microeconomics to general equilibrium and macroeconomics. It'll still have microeconomics. They'll be fundamentally defined relative to each other. But I'm going to argue that to navigate the Anthropocene, we need a more general equilibrium. And just to give a note on why I'm smirking there is economists, like once you get into the PhD level especially, they love general equilibrium. And it just means, and we'll get into this, that all parts of the economy are linked, and they love it. It's so general, it includes everything. But it doesn't. It doesn't include the assumptions of the system, such as those from the environment. And so hijacking their language, we need to generalize this out. So it's not just general to all parts of the economy, but a general equilibrium that also includes the Earth. So the syllabus, you'll find it online. I took a little bit longer than I wanted to here, so I'm going to go slow or go quickly. But it's as you'd expect, so I don't want to spend too much time on this. We got learning objectives. One thing I will say is I'm going to be recording all these classes. However, attendance is still required, okay? And it's 10% of your grade, and we'll talk more about that next class, how I'm going to record that, okay? So the recordings are there for your reference, but don't use them as a substitute for coming in person unless you have a legitimate excuse. You will lose points, okay? Because this is important. I also want to say, let me know if you're not okay with me recording these. My goal is to put them on YouTube. I'm trying to create a massive online open course with this content to start to fill it out. The camera will always be on me. Your voice might get into here, but your image won't. But if you say anything that you don't want, or you just feel uncomfortable about this, reach out to me now before I post anything. But yeah, that's the idea. It's in person, blah, blah, blah. Oh yeah, the textbook. Eventually I'll be writing an open access textbook on this topic, but for now we're using this one, which is free through the U of M libraries. I think you have to be logged in to access it. So if that throws up a flag, that's why, but it's at that link. And the final thing maybe to note is that there's going to be the Canvas page, yes, but I actually don't want to use the Canvas page very much. It's only going to be for announcements, assignment submission, and grade reporting, but I hate Canvas. Because why? Well, everybody hates it, but more specifically because it's proprietary. It's a closed system. It's not freely editable by anybody. And instead, what we're going to use is our course website. And so I'll refer to, the course Canvas page is what you'd expect. But then the first thing it does is link to the course website, which is here. So you'll hopefully, whoop, nope, you can't see what I'm doing, am I? I forgot I have two screens. There we go. So, oh, this is awkward. So yeah, so there's Canvas, but not much will be on here. But you still will submit things, like assignments there. But it just links to our course website. And you'll find that that's where you can get the actual syllabus. I used to be a web designer, so that's why everything is on my personal website. But really, the critical thing is the schedule. And so this will be updated. The topics that we have and the specific dates, they may change a little bit. The ones that won't change are the dates of the midterm and the final. So that you can schedule on. This is an interactive course, and based on student interest, we may reorganize the topics though. And as we go, we'll be filling up links here. And so the readings for the next class Friday are there. There's two here. It's a really quick read on donut economics and the details of it, and an optional longer reading on it. But then we'll also populate this with videos and slides, and any notes on assignments are going to be here. I really didn't get through all the parts of the syllabus today because I kind of got long-winded, which I'm tended to do. But so I might hit on a few points next class. Other than that, I'm excited. You're free to go. But feel free to ask me any questions. We'll pick up where we left off. Do make sure you read that Donut Economics website. Thank you.